Welcome back to geometry. Today we are going to be finding the areas of irregular shapes. So areas of irregular shapes are just areas of shapes that we have already know how to find the area of, and we need to combine them together. So we're going to round to the nearest tenth if necessary. So here in this first example, notice that we have a shape what looks like a rectangle. And we have an empty spot here that looks like it is half of a circle. So we are going to find the area of our rectangle, and then we will subtract off half of the area of our circle. So to find the area of a rectangle, it's length times width, so 50 times 30. Then we want to subtract off 1/2. The area of a circle is pi r squared, so pi. The radius here, well, if this is 30, the radius would be 15, half of 30. So pi times 15 squared. Well, if we take 50 times 30, we get 1,500. If we take pi times 15 squared and then take half of that, we get 353.4 about. So if we subtract these from each other, our area of our shaded region here should be 1,146.6 feet squared. Second problem. Second problem appears to be that we have a rectangle, and then we have 3 open spots, and each open spot is a circle. So to find this area, we will take our rectangle, and we will subtract off 3 circles. So first, to find the area of the rectangle, we need base times height. Well, here this is 5. That's a radius, so we also know this would be 5. This would be 5, so this whole length here would be 10. Okay? Doing the same type of logic, if this is 5, this whole diameter of the circle is 10, and there's 1, 2, 3 of them, so this length would be 30. Okay, so finding the area of our rectangle, we will just take 10 times 30. And we're going to subtract off 3 times the area of our circle, which is pi r squared, so times pi, and the radius is 5, so 5 squared. Well, 10 times 30 is 300. And then we're going to subtract off 3 times pi times 5 squared, which is 25. So we're taking 300 and we're going to subtract off 235.6. And so if we do that, the area of this shaded figure is 64.4 centimeters squared. All right, let's look at a few more examples. Next up, this looks like it's a combination of 2 parallelograms. Notice that they're split in half right here. This has a total of 40, so that means each height individually would be 20. So the area of our parallelograms would be 2 times the area of our parallelograms. I say 2 because they do have the exact same measurements. Parallelograms is base times height, so this would be 2 times 24 times 20. So if we take 2 times 24 times 20, we get a total of 960 inches squared for the area of this first figure. Our second figure, we need to decide what this is of. Well, we definitely have a square right here, and it looks like a triangle. So we will take the area of our triangle, and we will add on the area of our square. Well, area of a triangle, in order to find that, we can do 1/2 base times height. So 1/2, we know this base here is 22. We know that because these are all marked congruent. So 1/2, 22. This height, well, if this whole length is 42, and if this length is 22, 42 minus 22 is 20, so that height is 20. So we would take, to find the area, we would take 1/2 times 22 times 20. Then we would want to add on our area of our square, which is just base times height. So in this case, 22 times 22. So half of 22 times 20 would be 220. And then we want to add on 22 times 22, or 22 squared, which would be 484. So 484 plus 220 is 704. So the area here would be 704 centimeters squared. All right, we still have a few more examples to look at. Next example, this one appears to be two triangles. Notice they're split right here, two separate triangles. So we're going to find the area of this triangle, and then we can add on our area of our other triangle. So here we have a triangle plus a triangle. So the triangle on the left-hand side, 1/2, the base is 38, and the height there is 14. Adding on the area of our second triangle, 1/2, this base on the right-hand side is 40, times that height is 10. So 1/2 times 38 times 14 is 266, plus 1/2 times 40 times 10 is 200. 200 plus 266 is 466 centimeters squared for the area. This next diagram looks a little bit trickier. When we're trying to decide what type of shape this is, notice that it definitely looks like we have some sort of triangle here. So we're just going to finish that triangle off. Ooh, and then look what we have here. We have half of a circle. So we're going to take half of our circle, and we will then add on our triangle. Well, half of our circle, 1/2 pi r squared. Well, this would be the diameter. So that means the radius would be half of that, or 1/2. So 1/2 pi times 1.5 squared, plus the triangle, 1/2 base times height. Your base there would be that 3, and your height would be 7. So if you take 1/2 times pi times 1.5 squared, you end up getting 3.53 about. And then if you add on 1/2 times 3 times 7 for the triangle, you're adding on about 10.5. So when you add those two together, the area is about 14.0, no label, so units squared. All right, just two more examples of irregular figures. The first one up here, if we take a look, this appears to be a rectangle and a triangle. So we will take the area of the triangle and we will add on the area of the rectangle. Well, our triangle is 1/2 base times height, so we see the base is clearly 12 here. The height of this triangle would be 20 minus 5 to give us 15. And then our rectangle, base times height, would just be 5 times 12. So if we take 1/2 times 20 times 1/2 times 12 times 15, we get 90. If we take 5 times 12, we get 60. 60 plus 90 is 150. There's no specific label, so we'll say units squared. And one very last example here. This one looks like we have a combination of more than just two shapes. Looks like we have a square, and we have a half circle. This middle shape in here is a trapezoid. So we're going to have to take the area of the square, add on the area of the trapezoid, and then add on half of our circle. Well, the square, that's 13 times 13. Trapezoid is 1/2 times height times base 1 plus base 2. So 1/2, we see that the height of the trapezoid is 20. The base 1 of the trapezoid would be 13, plus the base 2 here would be 30. Plus 1/2 of the circle, so 1/2 pi. If this is your diameter, the radius would be 15. So pi times 15 squared. Well, so 13 times 13 is 169 for our square, plus 1/2 times 20 times your 13 plus 30 is 430, plus 1/2 times pi times 15 squared ends up giving you 353.4 approximately. So when you add those three values together, the area of this irregular shape should be 952.4, and there's no label, so we'll say units squared. So that's how you find areas of irregular shapes. Essentially, you need to break it down into what components you actually know.